The bacteria can easily escape and be readily available to the next unsuspecting host. People that have AIDS will make a host much more susceptible to TB. Tuberculosis is second to HIV/AIDS as the greatest worldwide killer due to a single infectious agent. Symptoms of tuberculosis include, but are not limited to, body weakness, loss of weight, chest pain, fever, or night sweats.
All right. So, in 2011 alone, there were 8.7 million cases of tuberculosis around the world, and 1.4 million people died from the disease. Fortunately, between 1990 and 2011, the death rate as a result of the disease has decreased 41% from the years prior to 1990. To try to counter the still very high numbers, many people in developing countries have been given a vaccine. As you can see by the darker shaded countries, this indicates how heavy the cases are in that area. Tubercular bacillus in a live vaccine is given to the patient. Sometimes the vaccine that was meant to save someone actually infects and kills him/her. When the vaccine is given, or when someone is infected, the pathogen binds to an antigen-presenting cell, for example, perhaps a phage. This cell then recognizes that there is an infection, tries to degrade the pathogen, and binds to a helper T cell through the class II MHC molecule and accessory proteins. Once the cell binds to the helper T cell, interleukin-12 cytokines are released to bind to the IL-12 receptor on the helper T cells. T cells proliferate and try to destroy the infection by secreting antibodies that fight the infection. Both continue to release cytokines until the pathogen is removed entirely from the body. The T cells can also activate B cells. These B cells can turn into memory B cells that can later be used if the disease is introduced back into the body. The memory B cells are quicker to recognize an infection, and the normal immune response occurs at a much faster and effective rate.
Unfortunately, if someone has a mutation in the IL-12 receptor site, then they are unable to destroy the infection in the immune response of a person with a mutated IL-12 receptor site. The vaccine is introduced in the body, and the body is unable to create memory B cells to fight off the infection later. The IL-12 cytokines are released from the antigen-presenting cell after tuberculosis is introduced. As a result of the mutated IL-12R, the IL-12 cytokines will not be able to bind to the receptor site. Simply, they will not fit. Since the bond does not occur, the helper T cell does not proliferate to activate the memory B cells necessary to fight off the infection. Ultimately, the bacteria multiplies exponentially and the person gets sick from the vaccine. As time has progressed, various strains of tuberculosis have evolved. There's a multi-drug resistant form of TB called MDR-TB. This is another reason that all tuberculosis vaccines may not be effective in preventing the disease.
Our model is vital to the understanding of how the spreading of tuberculosis can be slowed down. Our model includes interleukin-6, shown in maroon, and glycoprotein 130, shown in blue. There is no crystallized structure of interleukin-12, but the interleukin-6 is a decent substitute since they are homologous. This means that they share common qualities of structure and function. The most important amino acid on the structure is tryptophan 142, colored in green. This amino acid is found in the center of the model near the binding site of interleukin-6 and glycoprotein 130. It is theorized that the problem may be derived through this specific amino acid. A mutation of the genetic code found in tryptophan 142, or the total deletion of that amino acid, may cause a drastic shift in function. The binding process of interleukin-6 with glycoprotein 130 will more than likely not occur. This would imply that the signal will not be passed on, and the white blood cells necessary for the neutralization of tuberculosis bacteria would not be released. Using a visual entity such as this 3D model will allow more research to be accomplished and may lead to a solution to the problem with tuberculosis neutralization.
Welcome to our little metaphor of what happens when tuberculosis attempts to attack the body, and the body is able to fight it off. So Lainey over there is tuberculosis. Brendan is Mr. T, or a cop. And Brandon is a hot dog vendor or store worker.
I think I'm going to cause some mischief today. Let's see what harm I can cause when I get into aisle 12. I don't see anyone protecting this area. I came to destroy and cause shenanigans.
Oh no, not TV again. Wasn't she here last week? I better call the police with a cell phone.
The cell phone represents the antigen presenting cell binding to or communicating with the helper T cell, Mr. T. Hopefully, Mr. T will take care of this burglar.
Hello, cops. TV is loitering in the store again and causing mayhem and foolishness. Send someone over right away.
I've received your message and I'm here to help. There's just one thing I need first to help me stop this villain.
At least it's Mr. T. What is it?
Donuts!
The donuts in this case represent the IL-12 cytokines.
Well, I guess you are the one that makes that stereotype true.
Stereotype or not, I need it. Don't hold out on me, punk, or you can deal with TB on your own. You must understand that eating donuts is necessary for me to feed my formidable foe.
What do you think this is? Some kind of Popeye spin-off? You're delusional.
Look, do you have any or not? I need my fix, man.
Well then, I guess you're lucky you still have some. You know, I am supposed to be a hot dog vendor. It may not be much, but it should help solve whatever fans seem to have about these things.
Finally, I must say, dog, it took you much longer than I expected. No matter, with these delectable morsels, I'll put an end to the so-called TB.
Brenda grabs the donut, which are analogous to the IL-12 cytokines. With the consumption of the donuts, Mr. T is now strong enough to take out the TB. This will stop the spreading factor and halt any other grocery store from being tormented under the wrath of TB.
Now we're going to rewind. This time our metaphor takes a different turn. This time the body is unable to get rid of the TB.
Today is the day for total annihilation. I will use my power to destroy this store, and then I will grow exponentially powerful and destroy every store in the world. Wah!
Oh, great. That TV again. You look like she's going to run amok again. At least she shouted out the plan to everyone. He's back again.
Sorry I'm late. I just had a huge fight with my girlfriend.
I'm supposed to feel sorry for you? Look at me, I'm a hot dog. I guess you have a point, though. Women, they cray. Am I right?
True that. I don't even know why I decided to show up.
Do your job? Whatever, I think I know what you need. Donuts. Maybe they can help you fight that nasty TV.
In this scenario, Mr. T was just dumped by his girlfriend and is in no great state of mind. He refuses to accept these donuts, and his problem with receiving this food will cause problems in the rest of the store. Let's see what happens.
I will not take these. I'm too upset right now. Let someone else get TB out of the store. I pity the fool who has to deal with that monster.
As Brenda leaves, TB remains in IL-12 to cause problems within the cell. Since the donut cytokines did not bind to the IL-12 RB1 receptor site, Brendan's mouth, the TB bacterium is left to multiply exponentially within the cell.
Wah! No one can stop me, for I am invincible.
There's just a few people we'd like to thank. We'd like to thank Richard Robinson and Hallie Miller for helping us with the project. Mrs. Grant and Mr. Guest for being awesome advisors, and Gina and Shannon for all their hard work. Thank you, guys.